For years now, China has been quietly making history on the moon, sending advanced robotic missions to explore untouched lunar regions. These missions haven't just gathered dust and rock. They've unearthed something that could shake the foundation of science. Among the countless discoveries made, one particular find has scientists buzzing. Something in those returned samples may have the power to reshape how we understand the moon's past and Earth's future. Unlike the dramatic human missions of the Apollo era, China's approach has been deliberate, methodical, and deeply focused on uncovering the moon's hidden truths. With every mission, they dig deeper, both literally and metaphorically, into the mysteries buried beneath the surface. But it's not just about understanding the moon as a lifeless rock. These explorations aim to unlock practical secrets, energy sources, water supplies, and perhaps even future lunar habitats. So what exactly did they find up there? The short answer: rocks and minerals that defy expectation, evidence of volcanic activity that lasted much longer than we thought, and even the building blocks of clean energy and water. These discoveries are only the beginning. China isn't just rewriting the history of the moon. They might be drawing the blueprint for humanity's next giant leap. The moon has always seemed like a quiet, predictable companion to Earth, a gray sphere that simply reflects sunlight and tugs at our tides. But as we study it more closely, we're realizing it's far more complex and mysterious than we ever imagined. And strangely enough, these mysteries don't just reveal things about the moon. They raise unsettling questions about Earth too. Our planet is unlike any other rocky world in the solar system. Venus, almost identical in size and mass to Earth, has no moon at all. Mars, though smaller, has 2 moons, but they're tiny, no bigger than cities. Then there's Earth, with a massive moon that's far too large to make sense compared to its planetary host. Why is that? This strange configuration has puzzled scientists for decades. Why is Earth paired with such a unique satellite? Why is the moon so geologically active in its past? And why do its rocks look almost exactly like Earth's? The more we dig, the less we understand. Every new discovery seems to contradict the last. It's becoming clear. The moon isn't just a dead satellite. It's a geological enigma, tied to Earth's history in ways we still don't fully grasp. The origin of the moon is one of the most dramatic and violent stories in planetary science. For decades, scientists struggled to explain why lunar rocks collected during the Apollo missions were nearly identical to those found on Earth. If the moon had formed elsewhere in space and was later captured by Earth's gravity, its composition should be vastly different. But it wasn't, it was too similar. That changed everything. A new theory emerged, bold, catastrophic, and backed by growing evidence. It's called the giant impact hypothesis, also known as the Big Splash. According to this theory, about 4.5 billion years ago, a Mars-sized planet dubbed Theia smashed into the young Earth. The force of that impact was so immense that it liquefied both planets. Debris from the collision was thrown into space, and much of it eventually clumped together, cooled, and formed our moon. Recently, this idea was tested using powerful supercomputers. After millions of simulations, one digital collision matched what we see today. Earth's core merged with Theia's, while the moon formed from the floating debris. It's a fascinating theory, but it's still just that, a theory. Yet with every rock collected, every crater studied, and every mission launched, we get one step closer to confirming how the moon was truly born. While the world looked elsewhere, China was quietly taking the lead in lunar exploration. Over the past 5 years, the Chinese Space Agency has launched an ambitious campaign to explore the moon like never before. Not with astronauts, but with robots. These robotic explorers have gone where no human or machine has been before, particularly to the far side of the moon, the hemisphere that always faces away from Earth. In January 2019, China made history when its Chang'e 4 mission became the first spacecraft ever to successfully land on the far side. It wasn't just a soft landing, it was a calculated step into uncharted territory. The mission deployed a rover called U-22, which began exploring the vast Von Karman crater, an ancient impact site in the moon's southern hemisphere. What makes this region so important? The impact that created it likely exposed materials from deep within the moon's mantle, a part of the lunar interior scientists had never been able to study directly. Previous missions, including Apollo, only scratched the surface. But with Chang'e 4, China accessed hidden layers of the moon's structure, revealing not only the moon's deep history but potentially clues to Earth's own early evolution. And this was just the beginning. In December 2021, something strange appeared on the far side of the moon. As China's Yutu-2 rover made its slow journey across the desolate surface, it captured an image that stunned scientists and space enthusiasts alike. In the distance stood what looked like a perfectly shaped cube, something that appeared oddly geometric, almost unnatural, rising above the barren lunar horizon. Speculation erupted online. Was it a strange rock formation? A monolith? Some even joked that it resembled the iconic alien artifact from 2001, a space odyssey. The Chinese team nicknamed it the Mystery Hut and directed the rover toward it, a journey that would take weeks due to the rover's slow speed and cautious path. As Yutu-2 got closer, the illusion unraveled. What had looked like a cube from afar was, in reality, just a jagged rock, its shape distorted by shadows, lighting angles, and the low resolution of the rover's early images. Digital cameras, especially in low-light or pixelated views, often produce square-like artifacts. Though it wasn't an alien structure, the event reignited public interest in the moon and proved something important. When exploring truly uncharted territory, even the ordinary can appear extraordinary. And this sense of mystery keeps driving lunar exploration forward. In 2024, China's Chang'e 6 mission achieved what no nation had done before. It returned samples from the far side of the moon. For decades, scientists had assumed the moon was well understood. After all, the Apollo astronauts had brought back hundreds of kilograms of lunar material. But here's the catch. All of that came from the moon's near side. Now, for the first time, we had physical evidence from the other half, the side that never faces Earth. And what Chinese scientists found was astonishing. The far side rocks were lighter in color, thicker in texture, and clumpier than anything seen before. They contained less volcanic basalt and were more rugged, stickier, and far more diverse. One piece of lava dated back 4.2 billion years, making it the oldest lunar rock ever discovered. Even more surprising, many of the other rocks were much younger than expected, some just 2.8 billion years old. That's newer than many Apollo-era samples. This discovery overturned a major assumption, that the far side cooled faster and was geologically dead early on. Instead, it seems this side stayed molten and active longer than anyone thought. The moon, once believed to be a quiet, frozen world, turns out to have a much more complicated and dynamic past. For all our talk about knowing the moon, the truth is, we've barely scratched its surface. During the Apollo era, US astronauts landed at just 6 locations, all clustered around the lunar equator. Why? Because those areas were flat, safe, and accessible. But scientifically, they weren't the most interesting places. In total, across all missions, astronauts only explored about 25 square kilometers. That's smaller than Disney World. Even with lunar rovers, their range was limited. Imagine an alien landing in just one theme park and then claiming to understand all of Earth. That's essentially what we've done with the moon. The Chinese, however, are taking a different approach. Their missions aren't limited by human safety concerns, which means they can target more geologically rich and challenging regions. One such mission, Chang'e 5, landed in the Rumker Dome, a massive volcanic formation in the moon's northwest. It's the kind of place Apollo never touched. What they found there was game-changing. The youngest lunar rocks ever collected, just 2 billion years old. This reshapes our understanding of lunar volcanism and proves the moon remained active far longer than we thought. It's a humbling reminder. When you explore only a small corner, your assumptions about the whole world or moon can be completely wrong. When we think of volcanoes, we picture dramatic explosions and towering peaks, fiery mountains spewing lava high into the sky. But on the moon, volcanic activity looks very different. Instead of violent eruptions, lunar volcanoes tend to leak lava slowly over time. This lava spreads out across the surface, forming broad, flat domes instead of tall mountains. One such formation is the Rumker Dome, located in the Moon's northwest region. This area became the landing site for China's Chang'e 5 mission. What made this mission so important was its sample return, the first since the 1970s. And what those samples revealed was stunning. Among them was the youngest lunar rock ever found, estimated at around 2 billion years old. That's significantly younger than the Apollo samples, many of which date back over 3 billion years. This discovery challenged a long-standing belief that the Moon had been geologically dead for billions of years. Instead, the evidence suggests that volcanic activity lasted much longer than anyone expected. The Moon, it turns out, may have remained geologically active well into its middle age. China's exploration is not only revealing new terrain, it's rewriting the Moon's entire volcanic history. And with every new sample, we realize the story of the Moon is far from over. Among the most groundbreaking discoveries from China's lunar missions was something no one expected: an entirely new mineral. Found in samples returned by the Chang'e 5 mission. This mineral was named Changesite, or more simply, Chang'e. It was tiny, smaller than the width of a human hair, but its discovery sent ripples through the scientific community. Why? Because this transparent, crystal-like mineral contains something incredibly rare and valuable: helium-3. Helium-3 doesn't exist naturally on Earth in large quantities. Our planet's magnetic field protects us from the solar wind, the stream of particles constantly emitted by the sun, which includes helium-3. But the Moon, with no atmosphere or magnetic shield, absorbs these particles directly into its surface. Over billions of years, it's become a vast reservoir of this rare isotope. Why is helium-3 so important? In theory, it could power nuclear fusion reactors, generating massive amounts of clean energy without dangerous radiation or toxic waste. Fusion with helium-3 produces no radioactive byproducts, making it one of the cleanest energy sources imaginable. The problem? We don't have working fusion reactors yet. But once we do, helium-3 could become the most valuable resource in the solar system. And right now, the Moon and China's growing presence on it might just hold the key to our energy future. For decades, scientists believed that if water existed on the Moon, it would be locked away in permanently shadowed craters near the poles, places so cold and dark that sunlight never reaches them. But China's Chang'e 5 mission changed everything. In one of the most unexpected discoveries, researchers found water not in a frozen crater, but on the sunlit slope of a volcano, specifically the Rumker Dome. This water wasn't liquid, of course. It was chemically bonded within a mineral called ULM1, a type of hydrated salt. Essentially, the water molecules were locked inside the mineral structure, like a combination of rock and ice. But here's the shocking part. This wasn't just isolated hydrogen or oxygen atoms. This was real H2O, a complete water molecule discovered on the Moon for the first time. Why does this matter? Because it completely changes the game for future lunar exploration. If water isn't limited to shadowy, inaccessible craters, then human bases could be built almost anywhere. Water is essential not just for drinking, but for creating breathable air and even rocket fuel. This discovery proves the Moon is not as barren as we once thought. And now, the potential for permanent human presence on its surface feels closer than ever.